Hi everyone, this is Rajkumar. This video we are going to discuss about how Java works. Okay, we all know the heart of Java is JVM, right? Java Virtual Machine. So that is what are helping us to execute the program. In this video, what exactly happening behind the scene when we execute a program, that is what we are going to learn. Okay, as I already told, JVM is Java Virtual Machine. If you want to understand what JVM is doing, we need to first understand what is virtual machine is, right? So I want to explain virtual machine with the help of virtual reality because most of us already know that what is virtual reality is, because nowadays even in exhibition we are seeing a stall with virtual reality, right? So see this image. uh, she is wearing a device in her eye, and whatever she's seeing inside the device, she feels that that's real and it's present outside also. Okay, that is what the device is, virtual reality device. Okay, so the virtual machine also similar to it. Okay, if you have a actual hardware, actual computer in placed, you can install virtual machine inside it, and you have a different operating system. It need not to be same as like what it present in a actual hardware. So but whenever that if you are accessing some application inside that virtual machines, you feel that like you're working on an actual machine, but it is not real. Okay, so other way I could say the virtual machine is called computer system emulator. Hope everyone know what is simulator emulator is. Simulator is basically if you have a software, and if you want to mark the software, if you don't have access to the software or something, like if you want to mark the software and get the same output, then that is called the simulator. Mostly it will be used in testing purpose. Consider you have some software which will do lot of operation, finally it will store that some informations into database. Okay, that is the purpose of the software. And if you don't have access to the software, then basically testers what they will do is they will create a simulator. The simulator basically it will actually do certain operation and finally store similar output to the database. So it's kind of like marking the software behavior into simulator. Okay, the emulator is nothing but marking a hardware to operating system, the platform behavior. That is what emulator will do. That is called as virtual machine is. Okay, if you see the architecture of virtual machine is this one. So it will have a host hardware with operating system, that's a real one. On top of it we will have a hypervisor, also it called as virtual machine monitor. On top of it there are multiple virtual machines we can install. And this operating system what we have it in host, right, that should not be same as the guest OS, meaning each virtual machine can have a separate OS in it, and whatever application is suitable for that particular OS, right, that we can install into that virtual machine and use it like that. And why we need this virtual machines, we need to understand, right? Consider you have developed an application and hosted into cloud. That cloud you maintain a operating system as Linux, and basically in your local machine you have operating system as Windows. Okay, if you want to test your application what you developed in a Linux environment, there are two approach. One is like you can purchase a separate machine, that involves cost as well as like you need to maintain a space and other things for that, right? So that's a one approach. But the other approach it be like you can install the virtual machines into your Windows operating system. There you can have a Linux operating system. In the virtual machine itself you can have a Linux operating system, and in that environment you can test this. That is what it is. Okay, this could be one example. Okay, this is as actually the problem statement which I mentioned, right? This virtual machine structure, it actually solve that problem statement. And like there are many problem statement we have, and that is even solved by this architecture. These type of virtual machine usually we called as system based virtual machine. And there is one more virtual machine also present, that is we are calling as a process based virtual machine. These type of virtual machine is designed purpose of running a single process, meaning single type of application. Example, if you have some, it's basically designed for or creating an environment to run a platform independent language or platform independent applications. To run that and execute, we need this type of virtual machine. Java virtual machine is this type of virtual machine only, process based virtual machine only, Java virtual machine. If you see the, we have JDK or JRE, we can install into Windows operating system, that in the physical or host hardware and operating system only, like will directly install JDK and JRE. And that virtual machine, the JVM, the purpose of only executing a Java program. And we know that, right? Java is platform independent language because of this reason. Similarly, there are other virtual machines also available. Parrot virtual machine, that's for Perl, and like CLR, the common language runtime, that is for .NET, and everything follows the same architecture of process based virtual machine. Okay, now I hope like we understood what is process based virtual machine, and this is the same architecture JVM also has. Now we will understand JVM architecture. What is Java Virtual Machine architecture? It has three different subsystem. One is called class loader subsystem. Inside class loader subsystem, it will actually do three different activity. One is loading, linking, and initialization. Then second subsystem is called memory area. Memory area also has five different area. One is method area, then heap area, stack area, PC register, and last one is native stack. Then finally we have execution engine present. Okay. Then if you have some native language or native code is present, right? That native code needs to be executed by Java program, right? That is why we have Java native interface. This one is responsible of executing a native libraries present. A native libraries is nothing but the library or a program which is written in a native language like C or C++. Okay, this is what the architecture of JVM. We will understand one by one. Okay, to understand JVM architecture, first of all we need to know what are all different terms which we are using in Java. Okay, so consider this is a class which we have written. What is class? First we need to understand. No, I have a school. Okay, I want to store each student level information. Okay, so what type of info and what is the schema I need to maintain to store a student information, right? The schema or blueprint that we can call as class, and it is kind of a data structure, I would say. So for this student, like I want to store student name, age, standard, and section. These informations I am going to store as part of each and every student, right? These structure which we are maintaining, right? This structure is called as class. Okay, then each and every parameter we are maintaining, right? This is called as variables. These variables, if it present to create an object, right, that variable called as instance variable. And then you will get a question that what is object. Consider this is structure. This structure is called a class, and I want to store each and every student information, right? If I am storing student information for Raj, and I am storing another student information called Kumar, then if I want to access Raj information, I should have some reference. And similarly for Kumar information, if I want to access, I should have one reference, right? These reference are address, I would say this is called as object. Okay, if the school is common and like it's common to all, right, then I don't want to keep the school in all the students record. I just want to keep it as common, right? Then that we can define at a class level. If you see, we have static string school name, and inside a static block I define a school name, right? Let's join hands and learn together. So this school and the stat is defined with a static keyword, right? This is called a static variable. As I already told, these are variables, and since it's defined with a static keyword, this is called a static variable, and the block of static is called static block. Okay, and if I have a method is nothing but it has a list of instruction present inside. Okay, so whenever I'm calling the method from somewhere, it will execute a list of instruction. I don't need to have it multiple places. I don't want to repeat the same instruction, so I will keep it as a method, and whenever I need, like I can call the method, it will execute the list of instruction. So it improves the readability of the code. Okay, and also gives some leverage. I will explain that later part of this video. If you see, and one more term is constructor, right? Constructor is nothing but like it's also a method, but it will have a same name what that class has. Okay, whenever I am trying to create an object for the particular class, the constructor only will be called. Okay, if we are passing a parameter to the method, these are called as parameters. Okay, then if you are passing a parameter to the constructor, then that's called a parameterized constructor. Okay, now we understood the terms class, what is object, what is variable, what is instance, what is instance variable, what is a method, what is constructor, what is static variable, what is static block, and what are all parameters. These we understood, I believe. We will see first two memory area. The first two memory area in Java or JVM is called method area and heap area. Okay, first method area. Method area is common to JVM. It's actually we will have only one method area for JVM. When JVM starts, right, it will create a method area. It will create a single method area. Okay, so basically, what level of information the method area has is it will have a class binaries. Basically, this will have a class level details. So the binary informations are like after converting into the byte code, it will be stored directly in a method area. And also all class level informations like this method informations and constant pool information, this constructors, these all will present in a method area only. Okay, and constant pool is nothing but like we have these symbols, right? Student name is one symbol, string is a symbol, age, standard, section, school name, these all symbols. Okay, will be these symbols will be stored in a constant pool inside a method area. Okay, so to understand, it will have a class binaries and class level data like static variables. Static variable is a class data, right? That will also store in a method area. Then constant pools, these stores all the symbols present in the class. And I already told, right, each JVM will have only one method area. Actually Java is a multi-threaded environment, right? It can have multiple threads to run, right? So since method area is symbol, multiple threads trying to access the same method area. If one thread is trying to access a particular resource, meaning particular class static variable, same static variable, another thread is trying to access it, meaning one thread is trying to write and other thread is trying to access it, it may create a problem. So usually whenever there is a single memory and multiple threads are going to access the memory, we will call that as a not a thread safe. Okay, the method area also a common one, and since it's a multi-threaded environment, we will call this method area as a not thread safe area. Okay, and the whatever the data which we are storing in the method area, there is need not to be a continuous one. Okay, there is no guarantee that the data will be stored in a method area in continuous manner. Whenever we are starting a JVM, it will create a method area. Okay, and another one is a heap area. Heap area, it is mainly used to store object level information, and even it will also show a class object to represent a particular class. Already we have seen a student class, right? When we are trying to instantiate a student object, first of all it will create a class object, then it will create a container. I will explain one by one. What is the difference between a first class object and instance? We shall understand. Consider you are a civil engineer and you are planning to construct five similar house in a same row. Okay, so what we will do, we will first create a blueprint for the house, right? That is called a class. Then each and every room, how much space I am going to allocate, that level of information, next level of information I will have, right? That is called as object. Consider I am able to calculate the estimate of single house. Okay, this is called as class object. I can repeat the same for all the house, right? That you can consider as instance. Okay, so if I have 5 house, I can do the plan and do estimate for single house. That same estimate I can repeat it for multiple all the house, right? I don't need to do a design from start, right? That is why the first one is called as class object, and the other one it we can consider as a instance. Okay, and like inside each and every object or each and every house, mm, the inside design or interior designs may differ, right? So that is how I want to store the data inside, that may differ. Like how much memory I need to allocate, I will come to know from class object. That won't change it for each and every instance. Okay, to understand that is why, to understand the heap area, first we need to understand the difference between a class object instance. Okay, so object level informations only, like we will store it in a heap area. Then each and every instance variable, how much memory I need to allocate, and that level of informations also will be present in heap area, because that's also object informations, right? And this is also single heap area present per JVM. Then that should not be a thread shape, and there is no guarantee that the data will present in a continuous manner. Okay, and this is also will be created when JVM starts. Okay, now we understand what is method area and heap area, I believe. So method area, it is like class level information we will store. Heap area, we will store a they will store a object level information. Okay, then next to this heap area, what we will have as a stack area. Stack area is also called as runtime stack. But even the first two what we have seen, it is actually common to JVM. If you are having a single JVM, you should have only one method area on heap area. But stack is not like that. Since Java is a multi-threaded environment, each thread will have a separate stack inside. Okay, this is called as stacks, and each and every entry in a stack is called stack frame. Stack frame will store method level information. Okay, and later if we want to, if that method is getting executed and all completes, then it will, the stack frame will release the method, the stack frame will be released from a stack, and this can be used for another method. Okay, and similarly, if the JVM completes the execution for the particular thread, then it will destroy the stack itself, and this area will be used for another thread. Are we clear? So the stack will be stored like this, and each and every entry in the stack is called stack frame. And whenever we are executing a method, that method will be stored in a stack frame, and method level information should be stored in a stack frame. And after executing a method, the particular stack frame will be releasing it from out of stack, and that stack frame will be used for another method in the same thread. And also once we complete the execution the thread level, then overall stack itself will be released, and that stack will be used for some other thread. Okay, as I already told, these entry called stack frame, and inside each and every stack frame we have three more entry, what is called as local variable array. Okay, local variable array is nothing but we have seen, right? Like if the method of like get student name, and also like we have seen a constructor method, right? There we have passed parameters, and also like we use some local variables, right? These variable information. So the local variable array is, it is a continuous memory, and each and every entry in the local variable array will take 4 bytes of memory. And how it will be stored is like a array format. The all the local variable inside a method and parameter which is passed into this method will be stored in local variable array. And next part of stack frame is operand stack. Operand stack mainly used as a place to store intermediate results. Example, I have a very big expression present in my method. If I want to execute during that time, like example, c is equal to a plus b plus c plus d, adding a plus b, the result should be stored somewhere. Then only like you can add that result with the c, right? So these intermediate steps, that information I need stored somewhere, no? That is what be stored in an operand stack. Another area is called as frame data. Okay, frame data, what we will store is like basically it will store all the symbols. As I already told, student name is one symbol, age is one symbol, right? Like these all symbols, the variables, like whatever we have seen at a local variable array, this will allocate a memory in local variable array and it will store the data of a local variable. But JVM doesn't understand exactly the address, right? It will understand symbols. So symbols meaning that student name, the variable name, right? That is called as symbol. That is also called as symbols. That will be stored in frame data. So we are clear, right? Now we will see this with some example. Consider I have written a class of stack understanding that we have a main function that is again instantiating a class called add. This is add is a class, and inside add like we have a method called addition, right? And like I'm actually instantiating a add class, and if I'm actually calling add dot addition function, add addition method, passing a parameter 2 comma 3.5. Okay, it will this 2 comma 3.5 I'm passing into addition method. Then I'm having a local variable double c, and if I what I'm doing inside is adding a plus b and store the results into c, and finally I'm printing the results. Okay, we will see what will happen behind the scene when we are calling a addition function. Since this main method we are calling, right, this is actually a main thread. It will, since it's a new thread, it will create a stack. Okay, it will create a stack, and we are calling addition function, right? What it will do, it will create a stack frame and for addition function, correct? Then addition function has parameter a b and local variable c. It will be stored in a frame data. Since frame data stores, what all it will store, it will store a symbols, right? It will store like that. Then what other concepts we have is local variable array and operand stack, right? We'll see. This is called a local variable array. Since we have integer a, this will take 4 bytes, right? As I already told, local variable array, each entry will take 4 bytes. Integer exactly will take 4 bytes. That stores 2 because like we are passing 2 to addition function, and that's a first parameter, right? That's what it happened. Next parameter what we are passing is b is 3.5, correct? So this double, this actually the data type of b is double is a decimal points. It will take 8 bytes of memory. Then the local variable array, next two entry it has to take, right? Each entry will take 4 byte, no? So it will take a 2 entry, and this is 8 bytes in memory. So it will have the data of 3.5, and this is actually pointed to B symbol which present in a frame data. Okay, then it will come to double C. This is actually a local variable. This is also double. So it will also take 2 entry in local variable array, and that is pointed to C symbols in a frame data. Okay, now what we are doing, C is equal to A plus B. That is how now operand stack will come into the picture. Okay, what will do exactly, first operand stack, it won't have any entry initially. Then first it will load A, correct? Then 2 will be loaded. Then it will load B. It has to add A and B, right? It both needs to present here, no? So it will actually load 3.5. Then it will do addition A plus B, 3.5 plus 2. The we don't need A plus B, A and B informations now. So it will actually add this to 2 plus 3.5. It's a 5.5 that will be stored in operand stack. Then now this 5.5 will be stored into this area in local variable array, and that's actually pointed to C symbols in a frame data, right? This is what happened. Then finally operand stack will be empty. It will actually pop out that 5.5 out of this operand stack since it's already loaded into C. Like hope everyone clear about this, right? We will move into the next two memory area present in Java. That's a PC register and native method stack. Whatever we have seen, first two is actually like common to JVM, and stack area it's actually thread based, right? PC register also thread based. PC register, what it will basically do is it will actually hold the address of current execution instruction or current executing instruction. What is the address, that information it will store. Java, since it's a multi-threaded environment, it will have multiple PC register for each thread, because threads will run parallelly, right? So each and every thread will actually run a different instruction, no? So that is why we have different PC register present for each and every thread, and each PC register will hold the particular thread, the address of current running execution instruction. And next, whenever the instruction is getting executed, it has to actually move on to the next instruction, right? Then only a JVM will take the particular address from PG register and add it into 4 bytes. If it is, the architecture is 4 bytes, it will add it to 4 bytes. If it is 2 bytes, it will add it to 2 bytes, kind of like it will add and go to next instruction and execute it. Since it's added address will be stored in a PC register, because that is a current execution instruction. Hope we clear, right? Each every thread will have a separate PC register, and each PC register will have a address of current running instruction of the particular thread. And JVM will take, once after executing the particular instruction, JVM will take the address, increment it and store it back to PC register, and that address instruction it will start execute. That is what PC register. Okay. Similarly, we have method stack, native method stack. Only difference between a native method stack area is whenever we are having a thread, it will create a stack area, right? For native method stack also, whenever we are whenever we start executing a particular thread, it will create a native method stack. And stack area, stack frame, what it holds a method level information. And whenever we are executing a method, that method it has to be defined by us, or it should be present in a JVM or something. But if we have some native methods like hash code or wait, these are the native method. Native method is nothing but a method which directly operates on top of operating system and will be returned by native language. Okay, these methods called native methods. For this methods, these method level informations will be stored in a native stack. It won't be stored in a stack area what we have seen. That is a difference between a native method stack and stack frame. There is no difference other than this. Okay. Okay, now we understood what is a memory area. We have seen what is method area, heap area, stack area, PC register, and native method stack, right? This is a memory area of JVM. Now we are going to see class loader subsystem. Class loader subsystem, as I already told, that has a three different activity. One is loading, then linking, then initialization, right? First of all, we will see what is loading. Loading, to understand loading, I'm just taking one example. Consider we have a main class available. There I have a main method, and also like we have a class called bottle. Okay, this bottle class, like I'm actually instantiating and creating a variable called or a object called b1 b2. Then I'm just, what I'm doing is I'm printing, trying to take a class of b1 and b2 and just checking that is both are same or not. If it is same, it will return true, otherwise it will be false, right? So what will happen when we do loading, we'll see. So first of all, first we need to understand what is a class file, dot class file, from where it will generate, right? If we have a dot java file, then if you are giving this dot java file to compiler, java compiler will generate a dot class file. This we have even seen it in a previous video itself, right? So that class file will be stored many places. Okay, the class loader subsystem is responsible of loading the class. Okay, that's a first point, that loading activity, the class loader subsystem will responsible of loading the class. Okay, well, I already told, right, there are many methods are available, sorry, memory area are available, right? We will see first memory area is method area, and next one is heap area, and also like we have stack area and other things, right? So first of all, JVM come across this one, it is trying to run a main method. Since it's a main thread, what will do, it will create a stack area for it, correct? Then it is trying to identify these symbols. What are all symbols present? String is a symbol, arc is a symbol, b1 is a symbol, bottle is a symbol, b2 is a symbol. Okay, these are all different symbols which we are seeing it in class. It will be stored in a constant pool, correct? So first constant pool of main method or main class binary, correct? That will be present in a method area. Okay, when JVM try to execute this, first of all it sees string is a symbol present. This identifies this a class. Okay, is this class present in our memory or not? First it will check. Okay, if it present, like it will take from that. If it is not present, then it will request a class loader subsystem help to load the class wherever it present. Okay, so consider the heap area. I already told, right? We have a class objects. Class object where it will store, it will store it in heap area. The instance also will be stored in heap area, right? So basically the string class object, is it already loaded in heap area or not? That is what JVM check. Okay, if it already loaded, it will take that reference. If it is not loaded, then it will ask or request a class loader subsystem to load. Okay, now consider string is already loaded. Then bottle it is trying to request, and when we try to when JVM tried to check it in a heap area, it couldn't find bottle class. Then what will do? It will request a class loader subsystem to load bottle class. Then class loader subsystem will try to find the bottle class from multiple place, and it will load it into method area as a class binary. Immediately after creating a class binary in a method area, then it will create a class object to represent a bottle class in a heap area. As I already explained, what is a class object and what is a instance variable or what is an object. This is what I explained with the similar houses which actually constructed by a civil engineer. What they will do, they will first create a plan that's called as class. Okay, that's called as class. That's a blueprint or class. Then how many room I need to have and how much size I need to keep, and like how much budget will take for single house. That level of informations we are doing, right? Initial plan for single house we are doing, right? That is called class object. Then instance, the b1 b2 are all instance, same thing. I don't need to repeat it. I can actually copy and use it for another houses, right? That is called instances. To understand that, I'm just explaining like that. See, we have the b1 instance is created, right? For that, so we can see the symbols is present in a stack area because the main is the method. So it will create a stack frame in a stack area for main method, and b1 b2 will be stored in a frame data, as well as b1 and b2 is a object reference. It will take a 4 bytes and will be stored in a local area array, and exactly that memory object informations will present in a heap area, right? This container b1, right? This is what it will have an object level informations. What it will hold, consider if we have seen it with student class, right? Student class, student name, age and section, these informations we have, right? That informations will be present in the container, and overall the b1 object reference or address only present in a local variable array of stack area or stack frame. Okay, and next, now we are clear, right? So what it is doing, JVM is checking is it loaded or not. Okay, it's not loaded. Then finally it will actually add a class binary of bottle into method area. Then immediately the class object to represent this bottle class will be created in a heap area, and that will be pointed by this b1 object, and that has this b1 and b2 in a local variable array. The b1 will have a address of this container. Okay, and next bottle b2 new bottle which we are creating it, right? Now JVM is trying to check it in loader class, yes, class object is already present for bottle, so I can take it like that, like JVM will understand and it won't request a class loader subsystem. It will create a container for B2 and now the B2 frame data address will be added with this container and the symbol of B2 in a frame data of a stack frame will be mapped to the particular local variable array of a stack frame. Are we clear? We hope we understood what is a class binary, what is class object, and what is the instance, and how this instance is mapped into a stack area. Okay, how this when the class loader subsystem will load the class into a method area and heap area. These we understood, right? Whenever there is no classes present in a heap area and method area, then only JVM will request a class loader subsystem to load the class. Otherwise, it will start to use the class. Already in the third statement, right? B1 dot get class and B2 dot get class, it will give true because like both the container with is actually pointing to a same class object, right? So it will give a, but how class loader will load the class? That could be a question, right? We will see. For that, we need to understand a type of class loaders. Okay, there are three type of class loaders available. We will see one by one. First one is bootstrap class loader. This is a parent of extension class loader. Basically, this bootstrap class loader will load the core Java libraries. Okay, core Java libraries is nothing but a base libraries. Java util, Java lang.string. These are the basic libraries which are already present in a JVM and that will be loaded. This is called a core Java libraries. Okay, before and before Java 19, Java 9, the path of core Java libraries present under JDK slash JRE slash lib folder. Okay, all the base libraries present in rt.jar. Okay, after Java 9, they have done a restructuring. They have restructured it. The rt.jar file itself, like they removed it in after Java 9. Okay, so if you go and search this one and try to identify a resource through code, it will present, it will actually give a path in a JRT format and that will present in java.base package. Okay, so before Java 9, the Bootstrap class loader, it is implemented not in Java, it's implemented in a native language like C or C++. So whenever in a Java program, if you want to identify the class loader which loaded the class, right, for the Bootstrap class loader, it will give null because it's implemented in native language. It doesn't have any object in it, right, or any dot class file in it, right? That is why it will give a null. But after Java 9, it's even implemented it JVM itself. Even though it's implemented in JVM, it will give a null because of backward compatibility. Okay, then next to bootstrap class loader is called extension class loader. Okay, bootstrap class loader is responsible. Okay, if I want to load a string class, Bootstrap class loader is responsible for this because string class is a core Java library. Platform related classes, maybe like java.sql, these package timestamp or sql.date, these package or these class if I want to load, then the responsible person is extension class loader. Okay, this is actually a child of bootstrap class loader but parent of application class loader. Okay, this extension class loader before Java 9, it will present in a path of JDK slash JRE slash lib slash ext. Inside ext only, we can see that. Okay, this is implemented before Java 9. It is implemented in Java only. Even now also it is implemented in Java only. But the Java class is sun.misc.launcher dollar symbol extension class loader dot class. That's where the class implemented and it present. But after Java 9, how they have removed rt.jar, they also removed this extension path itself. Okay, now if you want to search the resource that is present in a java.sql package, if you want to see a timestamp, that will present in java.sql. Similarly, if you want to see some other class, platform class, that will present in a class, but it will return in a JRT format. If you try to execute it from program and identify a path of it, it'll give in a JRT format. Before it will give a exact path where it is, because like it will present in a ext folder only, right? Now it won't present in ext folder. After Java 9 or from Java 9, the extension class loader renamed as a platform class loader. And the path also, that the Java implementation also got changed, and this is a exact name, exact package with the class loader class name, jdk.internal.loader.class loader, the dollar symbol of a platform class loader. Okay, then but whatever class which I am writing, I should from where or which class loader is responsible for loading, that I need to know, right? That is called application class loader. This application class loader only loads the class which is user return one. So basically from where it will actually load, this one is like it will load from a class path what we defined in a environment variable or in a current working directory. From that it will actually load the class. That is the purpose of application class loader. There is no change in application class loader before and after Java 9 other than the way it implemented and other things. So the implementation alone, before it is a sun.misc dot launcher app class loader. From that, like from the package we are able to see this app class loader dot class, but now it got changed to jdk dot internal dot loader dot class loader dollar symbol of app class loader dot class. I have just written a program to understand exactly like which class loaded what and where exactly it present. If this one I have actually executed with jdk 20. If you have lower version of java 8 or 7 or something, then if you write, then you can see the difference between a java 9 and before the edition. Now to understand this program, first like we have taken a string. The string would loaded by bootstrap class loader, and what will actually return is null, right? That is what it return, you can see. Okay, then I try to print the string dot class resource where it present. It shows that java dot base package it present this, and it will give it in a JRT format, right? But in lower than Java 9, if you try to see this from Java 8 or something, if you try to see this, it will clearly show that jdk slash jre slash lib slash rt.jar exclamatory symbol, and what is this like java.lang dot string dot class kind of it will show. Okay. Similarly, next one is timestamp. Timestamp, it's actually SQL timestamp. This is a platform package, right? I try to see what is this object or this class loader, or which class loader loaded this class. This shows it's a platform class loader. Okay, and where exactly it present in a java.sql package, and it shows in a grt format. Fine, right? Then test class which I have written, and that I try to load it, and I try to see which class loader is responsible for load this class. It clearly shows us it is application class loader. Now we understood, right, like which class loader is responsible for loading which class, which is a higher priority we should know, right? That is where we need to know delegation hierarchy algorithm. To understand this delegation hierarchy algorithm, see, first JVM request a class loader subsystem to load a particular class. What will do? Class loader subsystem will send this request to application class loader. Then application class loader won't search it in the application class path. This will delegate this request to the parent of this extension class loader or platform class loader. Extension class loader won't search it in extension class path. Then it will delegate it to bootstrap class loader. Bootstrap class loader will search it in a bootstrap class path. If it present, it will load, and that loaded class will be visible to child classes. Okay, then if it is not present, then it will delegate the request to extension class loader. Now extension class loader will try to check that in extension class path. Since it present, it will load the class, and that will be visible to application class loader. Okay, but it won't visible to bootstrap class loader. The loaded class will be visible to child, not to parent. Okay, consider if that extension class loader also not able to find the particular class, then it will delegate the request to application class loader. Now application class loader will try to identify it in the class path which we have given an environment variable or in the current working directory. If it present, it will load. If not, it will give a no class def error or class not found exception. Are we clear? How class loaders, which class loader will take the precedence to check it from their respective class path and load the class? That we understood, right? This algorithm is called delegation hierarchy algorithm. I hope we have a clear idea how class loader works, right? Then the class loader subsystem is the next functionality is called linking and then initialization. We will see first what is linking. Linking is also have three different activity. One is verify, another one is prepare, another one is resolve. Verify, what in this act in this place what it will do is bytecoder verifier. That's called in JVM we have bytecoder verifier. This one is responsible of verifying whatever we have it in a class dot class file. It is prepared by a correct or proper compiler or not. That is what it will expect. One example in that, like we have magic number will present in a class file. If you have created a dot class file, first 4 bytes it will actually take it for a magic number. If you remove the first line and try to run java dot particular class file, it will give a linkage error. Okay, the magic number is not correct, kind of like it will give some error. Okay, this verifier will responsible of identifying is the class file it is generated by a correct or proper compiler or not. That is what this one and will actually check and verify it. If it is not correct, then it will give a linkage error or verify error. Okay, then next phase is called prepare phase. In this prepare phase, JVM will allocate a memory to static variable of the class. Okay, it will only allocate a memory and assign with the default value. It won't initialize with the exact value or original value what it defined. Okay, prepare phase it will allocate a memory and assign a or initialize with the default value. It won't assign a original value. Original value means like in a student class, if you see that, right, like what I have written, static student, the school name is let join hands learn together, right? What it will do, it will give student name and it will allocate a memory, and that memory it will give null. It won't actually assign a value, it will just give a null. That is what done in a prepare phase. And result space, what it will do, it will actually assign a memory reference of all the symbols, like whatever we have seen it in a constant pools, those symbols, symbolic reference where exactly that memory presents, right? That mapping will be done it in a resolve phase only. These symbols, okay, this is where like memory present for this symbol, this for this symbol, okay, this is where the memory present. That the simple symbol to memory, the mapping will be done it in a resolve phase only. Okay, after that, like this is what the three phases which present in a linking place. Then initialization phase, JVM will assign original value to static variable, like as I already told, right? A static variable will be assigned with the default value. In a prepare phase of linking, in initialization it will be assigned with the original value. Now the school name will be assigned with let's join hands and learn together. That is what a school name assigned in the initialization phase. And it also have a responsibility to run a static block. Like if you see that student class, we have a static block present, right? The static block will be executed in this phase only, initialization phase. One more subsystem it's present is called execution engine. We will see basically what it will have it in execution engine. Execution engine, there are only two terms. We will see first one. Execution engine only responsible for executing the program, right? So first of all, how the execution engine, we have a interpreter present. We also know what is compiler and interpreter. Java, which is already compiled, and like we got a dot class file in a compiled format. Okay, then execution engine, the class file will be given into execution engine. The interpreter will take the precedence and it will execute it line by line. Okay, what it will do, first line it will read and then it will convert into byte code into machine code of the first line, then it will execute. That is what basically the execution in the interpreter will do. Okay, interpreter, this is what they'll do. The problem here is, consider I have method. The method I am actually calling and executing it. First time I am calling and executing it. What will do, inside the method, first line byte code to machine code execute, second line first line to machine code, so byte code to machine code execute. That is how it will execute. And second time if I am calling the same method, it will do same operation. Third time same operation. How many times it will actually convert the byte code into machine code and execute it? It's like unnecessary, right? Already we know, right, like this method is a this, okay, the same instruction I'm going to run, and I already converted that from bytecode to machine code. Why I am again converting that to bytecode to machine code? It's unnecessary, right? That is why there is a concept added in JVM or Java is called as JIT compiler. It's also called as just in time compiler. Okay, what it will do, it will actually check that, okay, I'm actually executing the same method multiple times. It will have a it will actually have a counter. I'm executing first time, second time, third time. Okay, I have a counter, and it actually reaches a threshold. We have profiler present in a JIT compiler. This profiler is responsible for identifying those methods, and these method is called a hotspot methods. Okay, these method JIT compiler what will do, okay, I identified these method executed more than the time what it actually has to execute, then we I will consider that this method most important method and it will be run by JVM multiple times. So I will convert this method byte code into a compiled machine code, and I will keep it, so that next time interpret when next time JVM try to execute that method, it won't convert then from bytecode to machine code every time, and it will take this machine code and execute it. Okay, that is why we have a JIT compiler, and it will actually identify the hotspot methods. That method alone will be converted into a machine code from a bytecode. Okay, not all the methods. Even some advanced JIT compiler are also available. What it will do, it will do a recompile and optimize that method to execute it very fast. Okay, it will optimize the method and convert it to machine code and keep it, so that it will execute very fast, since it's the same type of instructions we are executing multiple times, right? That is why the JIT compiler introduced in Java.
Okay, apart from execution engine, we also have native libraries and Java native interface. Native libraries, it has all the libraries which is written in a native language. And if I want to access that library, I need a Java native interface from JVM. Okay, native libraries is nothing but consider we have hash code method and wait method. This is basically will interact with the platform using a native language. Like if you have a DLL, which is actually written in C or C++, if you want to access the DLL from Java, this can be achieved with Java native interface. Hope you understand what is JVM architecture and how Java works. Thanks for watching.